So yeah, let's go ahead and jump into Inventor. And what we're going to start with is this assembly here. And the goal here is to actually create a cam on this. And we can see we have this valve. It's able to open and close. And we want to create a cam on this shaft here to get the desired motion into that valve. So to do this, we're going to go ahead and get into a different environment to accomplish these goals. First, what I want to do is just place one more constraint here to basically give myself a zero position so that later on I can drive this from that position. So I'm just going to go ahead and place one flush constraint here from there to there and just accept that. And just so it doesn't lock me down right now, I'm going to go ahead and actually suppress it for the moment. So as we got that, I'm going to go ahead and jump into a different environment. So just hit our Environments tab here. And let's just notice a couple things while we're here. I'm actually using Inventor Pro. And one thing you can see here is here's the dynamic simulation stress analysis. These both come with Inventor simulation package. Here's cable and harness, tube and pipe. This comes with the routed systems package. The Pro has all of this, as well as you get the tooling portion. For today's demonstration, we're just going to show portions of the simulation package. So let's go ahead and jump into here. And once we get into here, we can see that there's some different conditions here. Grounded components, some external loads. There's gravity, which is not defined yet. What we could do is place some joints. And we could do that by just hitting our Insert Joint command here. Notice there's revolution joints. We can also place cylindrical, spherical, point plane, all these different types of joints. Also notice there's actually a thumbnail representation of these. Notice the spring joints, cylindrical or prismatic sliding joints. We could grab those. What I want to do, however, is not do these one by one, but being that we made an assembly, we can use that to our advantage. So I'm just going to go into my simulation settings, and notice this checkbox here. Automatically convert my constraints to standard joints. So I'll just select that, say OK. Now, over here in my browser, you can see it's changed. Right here, I've got standard joints, some revolutions, some prismatic sliding type joints. I've got some point plane constraints. So you can see there that point of that follower hitting that rocker, for instance. What I want to go ahead and do now is basically be able to drive these constraints. So I need to make some rules, if you will, to how these are going to react. So I can go, and like I said, I want to be able to open and close this valve. So that joint, I'm just going to go to its properties and go ahead and place some initial conditions on it. So the position, for example, I said I created that flush constraint. I'm going to set that offset to be 0 according to that constraint, which will then in turn put that flush right there and make that the 0 point. And I'll go ahead and place some motion in here. So I can enable some motion, and I want position. I want this to follow a certain path. And notice I've got two conditions here, a constant value or the input grapher. I'm going to go ahead and place the input grapher and open that up. And we can see right here we've got different conditions we can place in here. So linear ramp condition, sinusoidal, maybe a spline condition. I can add these rules over here. Just add those conditions. Notice, say for instance, I do sinusoidal. Add that condition. I can place the amplitude, give it a value, the frequency, the phase. For right now, I've established some conditions ahead of time, so I'm just going to go ahead and clear what I've just placed there. And I'm just going to add a path which I've already made. So I'm going to grab this path, open that, and we can see this XY coordinate points of how I want this thing to follow. So go ahead and accept that. And did not hit OK. Let me try and grab that one more time here. Open. And OK. And we can see a little thumbnail representation there that it does indeed have that path for us. So I'll say OK. One other condition I need in here, I've defined that I want this valve to go a certain path or position. And also, I want to change the properties of the shaft. And I just remembered something I did not check, so let me go back into there real fast. I need to change the properties of that one really quick. I needed to change this value here. I accidentally let that be a negative value. I need the X and Y position to be relative 0 starting point and end point. So I'll go ahead and set those. And from 0 second to 1 second. And I'll accept that value. Now let me jump back to the shaft. This shaft is going to have a rotational value. So I'll go ahead and grab that. We can see that revolute there. And I'll go into its properties. And again, I'm just going to set some conditions here. So there's the initial state condition, the position of it. I also want to impose motion on it. So in here, I want to actually drive the velocity. So with that, again, constant value or input grapher. In this case, I'm just going to do a constant value. So here, I'm just going to say 60 RPM. And go ahead and input that value. And with that, I should have the conditions defined and be able to play and see this thing act accordingly. We should see the motion of that follower come into play here. Okay. And now I want to actually output that path. So I can go into my output grapher. And with that, I can actually add what's considered a trace, or add that path that we made it follow. So let me kind of shrink this up so we can see this in the actual assembly. And I'm just going to add a trace, or a path if you will. And I'm going to add the trace to the cylindrical portion here. So the origin point of that circle. And I need it referenced to the rotating portion, which is the shaft. So I'm just going to say there. And we'll see that update. And so as that position was defined, and as that shaft rotated, that's its relative path related to the shaft. Now with that, I can go ahead and take that trace and export it to a sketch. And what I can do is take that sketch and export it to a certain part, for instance this shaft. So from there, I've done that. I'm going to just close my output grapher and go edit that part. And then in this part, we can see that I have my sketch now that I output. And we can see what we actually have here is a spline following those XY coordinate points. So with that, I want to go ahead and edit my sketch. So I'll edit that. And reason being is because of the choice of point on the follower, we can see that the follower is not actually going to follow right there. It's going to follow along that path. And I know that the dimension from here to there is a 5 millimeter radius. So what I want to do is just simply offset this sketch inward a distance of 5 millimeter. Easy as that. Now with that, I can go ahead and finish my sketch. And from there, I can go ahead and extrude this out. And notice here a couple different options here. I could just simply do what's considered a join this to this part, or I could create a new solid body, basically a new part. So if this were going to be inserted on a keyway or a spline on the shaft, I could create this part as needed to create that condition. Right now I'm just going to leave it as join, and the profile I want